Every year, over 100 billion aluminum cans are produced. It's one of the most cherished metals in the world. It bends like paper and endures like steel. It's used for preserving food and beverages. But how are millions of aluminum cans made? In this video, we will discover how Coca-Cola cans are made from the moment they're recycled into massive aluminum rolls to when the cans are filled. Each week, the world consumes a staggering 4 billion cans of carbonated drinks. While it's nearly ubiquitous today, aluminum was absolutely revolutionary when first used in the 1890s. 150 years ago, it was more expensive than gold. Carbonated drinks weren't sold in aluminum cans much until the 1960s, but since then, cans became so popular that Americans use over 100 billion aluminum cans every year. About 45 billion cans are recycled in the United States each year, with over 90% of this amount turned into aluminum ingots used to manufacture new beverage cans. This is the world's largest enterprise for recycling used beverage cans. They come from all over the world to their factory in England. Compressed into bales weighing up to 1,000 kilos each, containing up to 65,000 aluminum cans. The aluminum can compact or helps crush and compress loose cans into dense, uniformly sized blocks. The machine also wraps the solid blocks with strong, thin wires. This keeps the cans together, making them manageable and much easier to stack, load, and relocate. The compressed can blocks are loaded onto a conveyor belt and fed into a 340 horsepower crusher. Aluminum is difficult to sort because, unlike other metals, it can't be separated with a magnet. So the crushed bits pass through an optical sorter at a speed of 3 meters per second. The machine uses infrared sensors to determine what is metal and what is not. Aluminum contains contaminants like paint and lacquer. The clean aluminum bits are ready for the next phase. 2 furnaces reach scorching temperatures of 730 degrees and each handle up to 100 tons of metal. When aluminum melts, it reacts with the air, forming a layer of aluminum oxide that floats above. This unwanted oxide is the slag. A worker removes it with a giant steel spatula. A river of molten metal flows downhill to a holding furnace the size of a double-decker bus. Somehow, they need to pour the liquid metal into a mold. Inside, it will be cast into 3 imposing aluminum blocks. Layer by layer, hot metal is added and rapidly cooled with water. As it solidifies and becomes denser, it sinks further into the mold, allowing more aluminum to flow on top. After 2 hours, they have 3 giant aluminum ingots. Each one is 10 meters long, weighs 27 tons, and is made from 1.5 million recycled cans. Today, the demand for aluminum is so high that the ingots won't just sit there. Their transformation back into cans begins with a 900-kilometer journey to a rolling mill. They're heated in another furnace to 525 degrees. This relaxes the atomic bonds, releasing any tension within the ingot. Then they're passed back and forth through a series of rollers. It's like stretching pizza dough. Each set of rollers reduces the metal's thickness to 1/4 of a millimeter and extends it to 10,000 meters in length. This forms massive aluminum rolls that are sent to Coca-Cola can factories. This factory produces packaging, mostly for Coca-Cola beverages. It can reach a rate of 2,200 cans per minute. The cans start as massive 9,000-kilogram aluminum rolls. About 700,000 cans will come from each roll. The process of making the cans is highly automated. Once the rolls are loaded, they're unrolled into sheets. The aluminum sheets are fed into a rapid press. This stamping press pushes the metal over 200 times per minute, creating the can ends. Each time this press comes down, it creates 14 can ends. The stamping press will form a 14-centimeter diameter. The stamping press will form a 14-centimeter diameter disc, then proceed to bend it into a cup shape. Excess material is compacted and sent back to the aluminum factory to be recycled into new rolls. A forklift carries the can ends to a resting area before they're moved to the next machine. In this machine, the can body is formed. Inside, a bar pushes the can ends through a series of progressively smaller molds. Making the can body requires a lot of lubrication to help the can ends pass through these molds. Proper lubrication is essential to prevent the aluminum from breaking as it's stretched. This lubricant also acts as a coolant to prevent overheating. That's why the cans come out with greasy residues. Once the body is formed, a deburring machine trims and straightens the edges properly. After this, a conveyor carries the cans upside down to the washer, where a 6-stage cleaning process takes place. The cans enter the cleaning area to remove oil. Part of the cleaning process involves sulfuric acid. The cans are sprayed with ionizing air jets. When cleaning is complete, they are ultra clean and ready for filling. Each finished can weighs less than 15 grams. Every single one is a pressure vessel. They must withstand nearly 3 times the pressure of a car tire. The cans are now ready for decoration. This rotating printing system can apply up to 5 colors. Applying the Coca-Cola logo to the can starts with a rubber mat rolled onto a cylinder. This cylinder is then installed in a machine called a decorator. It's a giant printer for cans. The dominant color used by this decorator is red. But it's not just any shade of red. It has to be Coca-Cola's red. The machine then sprays a varnish onto the inside of the cans. This creates a barrier between the beverage and the aluminum, preventing a metallic taste. It also prevents the acids in carbonated beverages from corroding the aluminum from the inside. The cans then move to a machine that forms a 5-centimeter neck. The flanger shapes a curved rim at the top where the tab will attach. Now all that's needed is the top lid. This process takes place inside a machine at a speed of over 2,000 cans per minute. Defective cans are immediately detected and recycled. Finished cans won't spend much time in the warehouse. Many are transported to the bottling plant, where they'll begin their swift journey to the filling area. Next, the cans enter the filling machine. A high-pressure carbonation machine introduces gas into the non-effervescent syrup. The soda cans are chilled to 5 degrees to prevent the carbon dioxide effervescence from escaping the can. The machine's valves can fill 130 cans at once at a speed of 1,700 cans per minute. The entire filling process is overseen by a single worker with a crucial task of ensuring that the capping machine never runs out of caps. Inside this machine, the caps are sealed onto the cans. The factory ensures that their customers receive fully sealed cans by using a gamma ray scanner. Cans with inadequate seals are separated and recycled. At this point, the cans are at an ideal temperature for consumption inside a box. Cold cans could cause condensation and dampen the cardboard. So they're sprayed with 35-degree water to reach the right temperature. After 12 minutes in hot water, the cans lose their chilly temperature. When they come out, they're around 27 degrees. Next, the cans need to be air-dried. Some cans end up in 6-packs bound by a plastic ring. Others end up in cardboard boxes. These cans will become part of a 12-pack in a year. A can be recycled and resold up to 8 times. If you want to know how McDonald's hamburgers are made, you can find the link in the description. And in the first comment, give the video a like if you enjoyed it and share it with someone who might be interested. Also, subscribe to this channel and activate notifications to keep learning.